picking up. Again, solve for y. An absolute value equation. So, solve for y. So then I'd have absolute value of y equals 7 minus x, and now it's an absolute value equation. And so you have to think back a couple sections of how we solved those. And it was rewrite 2 inside equal the positive, and or inside, I'm going to have to write smaller so I can get it all in there. Let's try again. So thinking back to what we did for absolute value, you rewrote to inside equals the negative, or inside equals the positive. So doing that, inside equals the negative. Well, all I can do here, and all I am going to do, is just put a negative in front of that whole expression. You know, back when we did it and when they were simpler little equations, you just had a 12 over there. So you wrote negative 12 or whatever it was. You took the inside equal to negative 12, the inside equal to 12. Well, we're still going to do the same thing here. Inside equal to the negative, or the inside equal to, and I'll be very specific, the positive. So we have y equals 2 expressions. And up there where I have it still highlighted in red, if after solving for y equals more than one expression, the equation did not represent a function. And so, absolute value of y plus x is not a function. Because they're each time, if I tell you what x is, if I say let x equal 3, well, if I use x equal 3 and I put it here, I'm going to get y equals 7. If I get x equals 3 here, or not y equals 7, if I let x equal 3 there, I would get 4. If I let x equal 3 here, I'd get negative 4. I'd get 2 y values. So it's not a function. Let's do it again. Again, solve for y. So y squared equal 25 minus x squared. Got a y squared. I want to have just y. So I take the square root of both sides. And very importantly, whenever I'm solving an equation and I take the square root of both sides, I have to include a plus or minus. And so I get y equals plus or minus the quantity, the square root of the quantity, 25 minus x squared, but what's important? 2 expressions. And so x squared plus y squared equals 25 is not a function. I got 2 answers. Let's do it one more time. And this is probably the trickiest one to solve. I want to solve for y. And so I need y equals stuff. That's what I need. I need a single y. I need to see a single y. I got x, y plus 3y. There's 2 y's there. So I got to figure out a way I can rewrite that in an equivalent statement. It can look different, but it has to be equivalent. An equivalent statement that has just a single y in it. And what I can do is I can factor out the y. And so I'll get y equals x plus 3 equals 7. And then I have to get that y alone. So I can divide both sides by that x plus 3. And so I get y equals 7 over x plus 3, but it's equal to one expression. And because it's equal to one expression, xy plus 3y equals 7 represents a function. Okay, last thing in this section. And if I had a color printer, it'd be much prettier, but I don't have a color printer. The bar graph shown below shows your chances of surviving to various ages once you reach 60. The functions f of x equal negative 2.9x plus 286, and g of x equals 0.01x squared minus 4.9x plus 370 model the chance as a percent that a 60-year-old would survive to age x. Find and interpret f of 70 as an ordered pair. Okay. So f of 70, that's not hard. That's just going to be negative 2.9 times 70 plus 286. And you just ask the calculator what that is. Negative 2.9 times 70 plus 286 comes up with 83. So an ordered pair, that'd be 70, 83. X's go in, Y's come out. And so the interpretation is the chances of living to 70 is 83%, given that you're already 60. This isn't your chances of living to 70 from birth, measured from birth. But once you hit 60, your chances of living to 70 is 83%. And I should probably word that better. The chances of living to 70 once a person is already 60 is 83%. Find and interpret g of 70. So g of 70 is going to be 0.01 x, not x squared, 70 squared, minus 4.9 times 70, plus 370. And the calculator tells me that that is that comes out to be 76. So as an ordered pair, that's 70, 76. And that would tell me the chances of living to 70 once a person is 60 is 76%. Then it says which function serves as a better model of surviving to age 70. So we go up here and look at this, and according to the graph, from the graph it's 86%. I could zoom in there and show it to you, but I'll just say that that says 86%. And so the better model is f of x equal to the negative 2.9x plus 286. It gave me an answer that was closer to the actual data. And that's one thing when we looked at a model before, that models aren't perfect, that they just approximate the data, and different models do better jobs. And so in this particular case, the model that was F was the better job as far as interpreting when we get to 70. Maybe it wouldn't be the better model for 80, 90, or 100. The other models might be better. Okay, and that's the end of this chapter and this video. Or not, excuse me, it's not the end of the chapter. Don't we wish it was in the chapter? It's just the end of this section and the end of this video.